Hello everyone. Today we are going to present our first project. I am Aixin Wang, and my teammates Jia Chenxuan and Huo Li. Next slide. This is our agenda. First, our introduce our C++ code, and next we will do part 1, stock analysis, and then Black-Scholes models for option pricing. Since it's our first project, it's an introduction of C++, we met some difficulty during the coding process. The first one is just how to sort stock prices or volumes along with their corresponding dates. During some research and trial, we figure out a way to sort the stock prices along with their corresponding dates. First, we separate them into 2 arrays, then sort price or volume or whatever the variable is, and find their indices. This is our code. It's pretty much similar with the sorted function, but in this line, we record the index rather than the stock price array. And then, since we find the index, we find the corresponding dates based on indices. Next slide. And then the next problem we encountered is output for part 1. It's just got masked using sample input data code, because the original code is, there's one line called char date 10. There's an array of characters defining dates, but since our data got online, it's formatted with month, date, and four digit years. It got 10 characters, plus the end markers. We have to have 11 slots during the array. So we modify the length of array to 15. So that works. So when solved our code difficulties, we got our codes, and the advantage of codes is first, generalization. We can easily get different results by changing 1 to 2 variables, such as constant int n, file name, or the variables. The next, for part 2, look at our results. We can print out many characteristics of an option, such as payoff, max value, the option price, plus 5 Greeks. We add a row based on our homework 3. Next, we have something to improve during further research, but I didn't do that yet. Maybe I will finish tonight. The function of calculating the normal CDF can be declared privately. It can ensure the security. For another we can use inline functions to improve the efficiency of programs, such as getting method and setting method. And we always check the input from users. We use CERR to tell the users whether your inputs are right or not. And then we can protect original data by using copy array functions. So we don't have to change the original array of the data. Yep. Next, let's come to the stock analysis.
Okay. Thanks, Yixing. Next, I will introduce the problem 1 of this project. Well, let's first look at what we are studying at in this problem 1. It's stock price and volume. When I read the problem at first, the first thing coming to my mind is, why should we do analysis for these 2 variables, the stock price and the volume? Is there any relationship between them? Well, we believe that when the stock volume is high, then that the stock price will have a relatively large movement. So here I use the Apple stock price and the volume from 2012 to 2013 as an example. In these two pictures, we can find that basically the point I just described, it seems to be true. But anyway, this is not the point of this problem. We mainly focus on the full moment. So next slide, I will talk about the fourth moment. So here is the final result of our problem 1. These four tables respectively describe the medium and the full moment of Apple and Google's price and volumes in 3 different time periods. So each of these moments and the parameters can tell us some information about how these data, in this case is the price and the volume, how are they distributed. So first, I believe all of you are very familiar with mean and median. That's just the average of the data and the middle position of your sorted data. And then it's the standard deviation. It just tells us the volatility of your data. In this case, it tells you the variation of your price or volume. And then it's third moment and the fourth moment, skewness and kurtosis. Well, in next slide, I will use 2 pictures to have an introduction. Next, please. Okay, here, firstly, I use the Apple stock price and the volume from 2012 to 2013 as an example. I plot 2 histograms to show the distribution of the prices and the volume. And I did my MATLAB and use the histofit, trying to fit a normal curve to approach the data. But obviously, in these 2 pictures, the red curve doesn't work very well to describe the data because we know the price and the volume are not normally distributed. So let's look at what the skewness and the kurtosis tells us. Well, first, skewness is a measure of asymmetric. When the skewness is negative, it tells us the distribution has a longer left tail, and a large part of the data lies to the right of the mean, including the median. So in this case, we can find first, through the histogram, we can find it really has a longer left tail, and the median is larger than the mean. So this information the picture shows us agrees with what we read from the skewness. And similarly, in the picture in the bottom, the skewness is positive, and we find it has a longer right tail, and the median is smaller than the mean. And then I will introduce the kurtosis. The kurtosis is a measure of I think it's a measure of the fat tail. The higher the kurtosis is, then the fatter the tail of the distribution is. So here we know the normal distribution has a kurtosis of 3. So in the first case, it has a kurtosis less than 3, which means it has a thinner tail than the normal distribution. And the volume distribution has a kurtosis of 5, which means it has a fatter tail, and more of the variations are caused by the infrequent extreme values in the tails. So, we can see again this information the kurtosis tells us agrees with what we read from the graph. So we can use these 4 moments to we just need to compare the 4 moments to compare the shape of the distributions of our data. So back in the tables in the last slide, we can use these 4 moments to compare the performance or the shape of the distribution of the price and the volume in different time periods, but unfortunately, I haven't found any reasonable trend or between the stocks or the different periods. So that's the part one. Next, let's welcome Guoli to introduce the problem 2 and the Black-Scholes model.
All right, I have 2 minutes left on the thing, and then I have to restart it. So, actually, hold on.